particle moves along the x-axis with the given velocity, sine of x minus pi over x, from 0 to 8, the particle is at position x equals 3 at time equals 0. Let's go ahead and plug that velocity function into our calculator. Did you guys get scared when we lost power today? It's kind of fun. I was in the school in time we lost power for 2 hours. 2 hours. I wasn't in school when we lost it for 5, but 2 hours. We went outside and played Scoot Your Buns for about 2 hours. Sweat like a pig.
Why couldn't I just go home? In fact, I don't feel like the lights turned off anyway, and I'm like, yeah, we're going home.
What would keep anybody from going home? Doesn't seem like that's ever a problem. People miss whenever they want to miss. That's up to your mom. Like, school's not saying you can't go home. People go when they want. So, sine of x minus pi divided by x. And I'm going to make sure that I'm working in radians, not degrees. I know that that's an issue from time to time. And I'll zoom standard just to get any idea what this graph looks like. I guess that's what we get. If you'd like a little bit more of a graph, just understand that if it's sine of x, the amplitude is 1. So if I change my window to, say, -2 and +2, I might get a better view. And also note that our, I'm sorry, we don't want the x value. The x value needs to go for sure all the way up to 8, as we want to see that data. And then I have y, I'm going to put -2 to +2. Can't stand this calculator. How does it type very well? There we go. On my way home last night, just kind of, it's a busy time of year. Got 2 miles from the house on the freeway and blow a tire on the freeway. Yeah. You don't like changing a tire on the freeway, right? But at least you know if you got a blown tire on the freeway, at least like the cars will move over for you, right? Especially the semis, because they understand what it is to be on the road. It's incredible. There were like 4 semis that could have moved over. There was nobody off the other side, but they just came right up next to me. I did give them a dirty look.
They were probably busy on their phone.
Yeah, I don't think that they cared. All right, there's our function. That's what we've got. Let's look at the first question. Determine the velocity. Tell me what to do. This is the velocity function. Just plug in 3. So I'm going to simply do v of 3. And so I don't care if you use your table or if you use second calculate and you choose a value, which is number 1, and you plug in 3, and we get -0.047. There is no label here, so we can just leave it like that. Determine the acceleration of the particle at time equals 3. Now what? V prime of 3 is equal to the acceleration at time 3.
Do you have to write V prime or can you just put A?
On the AP exam, they will want V prime of 3. There's no question. That will be part of your credit that you communicate you're taking the derivative of the velocity function. You need to show what you're calculating. So I go to second calculate and I select the derivative, which is number 6. I want to take the derivative at time 3, and so I do. And notice it shows the y value, which for me is confusing because the other calculators didn't do that. It also shows the derivative is 0.345. So we have 0.345. Any questions there? Okay, is the particle speeding up or slowing down at time equals 3? Talk to the person next to you. Go. Slowing down, right?
Why?
Because the velocity at time 3 and the acceleration at time 3 are opposite signs. If they are same signs, it is speeding up. If they are opposite signs, they are slowing down. Do you need that demonstrated, or do you have the general idea? Okay, velocity and acceleration, both will be positive. So right now, both are positive. You ready? Okay, now is velocity positive and acceleration positive. Here's velocity positive and acceleration negative. Yeah. Now, in this situation, the velocity was positive, or velocity was negative, acceleration was positive. What does it look like if velocity is positive, or velocity is negative, acceleration is positive? It looks like this. Okay, velocity is negative because I'm going this direction, but I'm starting to get back to going forward. So that's that situation. Question?
I already forgot. Oh wait, what if they were both negative?
If they're the same size, then it's speeding up. So here's what it looks like if they're both negative. Okay, I'm speeding up more going in the negative direction. Some teacher that I heard talk one time at an AP Institute, they said they like to teach their kids is their forces, and when they're the same sign, they're acting together. When they're opposite signs, they're acting against each other. And hopefully you could see from the demonstration what it looks like when they're acting together and when they're not. When does the particle change direction? How do we figure that out?
Or V.
Consider when V of t changes sign. Aiden is 90% correct in that we want to consider where it's equal to 0, because it changes sign when it is equal to 0. But just because it's equal to 0 doesn't mean that it necessarily changes sign, right? So they do want specifically on the AP exam for you to not say where is equal to 0, but when does it change sign? So we do look at the function that we have here. How many times between 0 and 8 does it change sign? Twice. And so we'll second calculate what? Zero, number 2. Enter and enter. And I get 3.141, happens to be at pi. V of t changes from negative to positive at time equals 3.141. This is exactly what they want you to write. V of t changes positive to negative at time equals, so now I'm going to look here, second calculate, number 2, enter, 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 and I get 6.283. So it looks like at pi and at 2 pi it changes sign. Very clear on that? Okay, find the position of the particle at time 5. I want you to just write down the expression, don't actually solve it. Go ahead, take 30 seconds, see if you could write down the expression for the position at time equals 5. Talk to the person next to you about what that looks like. Go. And that's what I should see. The starting position, which is 3, plus the displacement of the particle. Know what you got? Okay, so all we need to do is then 3 plus whatever that ends up being. So I'm going to go ahead, take this, I will second calculate. I'll do number 7. Do you think it's traveled more to the left or more to the right? More to the left because you have more area that is negative. Very good. So I'm going to go 0, enter, all the way up to 5, enter, and I get negative 1.549. So I'm going to take 3 plus negative 1.549. And I get 1.451. So it started at 3, and you're correct, it moved to the left from there. Find the total distance. What do I do for total distance? Yep, the integral from 1 to 6 of the absolute value v of t dt. This is the exact expression that they want. In fact, I've seen in numerous problems in the AP exam where this is worth 3 points. One for the bounds, one for the absolute value, and then one for the answer. So I'm going to go into this, and I'm going to choose y equals. You could either insert absolute values there, or you could go down to y sub 2 and simply go to an absolute value. In this situation, I do the absolute value of bars, and I grab my y sub 1 and dump that in there. So I'll go ahead.
You do second catalog.
So you could go into your catalog for absolute value, or you can go into math and over to numbers and find absolute value there as well. So I have on my absolute value function at that time. I will calculate on number 7. I should see that this function always stays above the x-axis, which it does, and I will integrate from 1 to 6. From 1 to 6. And I get 1.333. See if you can remember what you write down for average acceleration and average velocity. Take 1 minute, talk with the people around you, so you can remember what the expressions will be for average acceleration and average velocity. Go ahead, visit. Okay, what I'm looking for in this situation with average velocity, we are given the velocity function, so I should see a 1 over 8 times the integral from 0 to 8 of v of t dt. That is the average value of the function. That's our formula for average value of the function.
Why is it 1 over 8? Because
The only way I could really make sense of that is just if you were to add up 5 numbers, say 4 plus 3 plus 6 plus 9 plus 1, and you wanted to find the average, you would divide by that number of numbers, which is in fact 5. And so you add up all the heights and you divide by the width, which is 8. It's that type of idea.
what? Wait, so what's like the rule, I guess?
The rule is 1 over b minus a times the integral from a to b of f of x dx. That's the rule. So you got to look at the width of the interval, which is 8 units, and divide by that. Okay, so we've got that piece. And now for the next part, we'll calculate this in a second, but find the average acceleration. Well, acceleration is the rate of change. And if it's asking for the average rate of change, we simply use slope. So we're looking for v of 8 minus v of 0 divided by 8 minus 0. So those are the two that we're trying to determine. So let us calculate that. We'll do the first one. Go back into y equals, and I will deselect that. I will reselect the sine function, and I calculate number 7. And I'm going from 0 to 8. And I get negative 1.574. And then I'll have to divide that by 8. Can somebody on their handy dandy calculator tell me what that is?
Negative 0.196.
0.196? Okay, so that is the average height of that velocity function over that interval. Average acceleration, I have to do v of 8 minus v of 0 over 8 minus 0. It would appear that this function, if I go into my table and I type in 8, I get negative 1.124. And if I type in 0, I get an error. Oh, I forgot I didn't change that part of the problem. What does it look like you would get if you plug in 0 to this function? Negative 1, right? Yeah. Let's just use that for the sake of the problem, but they wouldn't put this problem on the AP exam because it would be incorrect. So negative 0.124, and we're going to minus a negative 1, and we're going to divide that by 8. So we add those together. I've got 0.876 divided by 8. So let me take 0.876 divided by 8. And that is the average acceleration. Okay. These are ones that we have practiced throughout this course. Notice that yesterday we did 2 other examples that involved area and volume. Those should really be at the heart of your understanding. And so if you see those on the AP exam, as you will see them on the test that I will give to you, those you want to know and know them well. So we will do another one, but this time you don't get a calculator. And so it says the particle moves along the x-axis with a velocity given by v of t is equal to, sorry about that, we will have 2 roots of t minus 6, and position t is equal to negative 2, and time equals 0. Sorry about that. So we're going from 0 to 12. It says determine when the particle changes direction for the time 0 to t to 12. So what do I look for when I look for where the particle changes direction? Changes the sign. And would it be good for us to consider the graph of this if we want to look at where it changes sign? Do you know what the graph of 2 roots of x looks like? Yeah, square root of x does look like this. Okay, looks like that. Okay, and if it starts shifted down negative 6 units, so it's going to start down at negative 6, and it's going to head on off like that. Can everybody grasp that that's the general shape of the function? Yeah, so we want to consider where it changes direction. Well, it would be at this spot right there, which as Aiden said earlier is where it's equal to 0 as well, right? So we're consider where does 2 roots of t minus 6 equal 0? And so if I add 6 to both sides, I get 2 roots of t is equal to 6. I divide by 2, I get the root of t is equal to 3. And so t is equal to 9. So v of t changes from what to what? From negative to positive at time equals 9. And that would be a very sufficient answer for that. They wouldn't require that you produce a graph, but producing a graph sure would help them know that you're not making a guess, that you in fact considered that piece. Determine the distance the particle travels, the total distance the particle travels from 0 to 9. Total distance from 0 to 9. Tell me something about the distance the particle is traveling from 0 to 9. Which direction is it traveling? So if this is 9 right here, then we would simply be looking at this area, which all would be negative. So it's not asking about the displacement, it is asking the distance. So what we calculate with that area should be negative, but it says total distance, so then we will take the absolute value and make it positive, okay? So we are going to consider the integral from 0 to 9 of the absolute value of v of t dt. And so let's take the antiderivative of this. What's the antiderivative of 2 roots of t?
Why are we taking the antiderivative?
Because we're doing the area, right? Anytime we do an integral, we got to do an antiderivative. So this is 2t to the 1/2 minus 6. What is the antiderivative of 2t to the 1/2? 2t to the 3/2 divided by 3/2 or multiplied by, so I get 4/3. Little trick I learned, turning your 2's into 4's. Minus what? 6t, evaluated at 9 and 0. If we plug in 0, you're going to get 0. So we plug in 9, and we trust that our result is going to be negative. So we will then just make it positive. So the absolute value of this is equal to, we plug in 9. I'm going to first take the square root of 9 to get 3 cubed. 9, no, 27 divided by 3 is 9 times 4, 36. So I get the absolute value of 36 minus, and then if I plug in 9 here, I get negative 6 times 9. That would be a negative 54. So 36 minus 54. Again, a calculator would not be allowed on this type of problem. What is 36 minus 54? Negative 18. So you have the absolute value of negative 18. So the total distance that particle has traveled is 18 units. Total distance. Okay. It says find the position of the particle at time 4. Let's first write the integral. What would the expression look like if we're finding the position? What would we start with? What goes out front?
Minus 2 plus.
Negative 2 plus the integral from 0 to 4 of v of t dt.
How do we know what to put on front here?
So it is, when you're wondering position is equal to the start plus the displacement. So the idea is, suppose I'm starting at a position of 5 and I'm displaced negative 3 units. What's my new location? My new location is 2. So we just think of where you're starting and how much you're displaced. Does that answer your question, Jojo?
Yep, I just forgot about that.
Okay, that's all right. So we're going to have this negative 2. Fortunately, we've done all the hard work in terms of finding the antiderivative. We will simply add to this, we have, again, 4t to the 3/2 over 3 minus 6t evaluated at 4 and 0. Obviously, we know that if you plug in 0, you get 0. We've already determined that. But let's do this other piece where we plug in 4. And we get negative 2 plus, and 4 square root is 2, cubed is 8, times 4 is 32, so we get 32/3. And then we have minus 6t, so minus 24. If you wanted to put this in one fraction, you could. If you left the answer as 32 over 3 minus 26 on the AP exam, they will give you credit for that. That's an accurate result. Though in this type of problem, it would probably be in a multiple choice if they had the answer like that. But I am going to do the extra work and just put it so that it has common denominators. 32 over 3 minus, and if I take 26 and multiply that by 3, what do we get, 78? 78 over 3. So as I subtract those, I get negative 46/3. And so that's the new location. The average velocity for 0 to 9. Are we given the velocity function?
Yes.
So then what is our formula for average velocity? Or 9 integral 0 to 9 of v of t dt. Do I already know 0 to 9 of v of t dt? What is it? Negative 18, isn't it? See that tricky part there? If you're not careful, you could put positive 18, right? So the average velocity is negative 2. How would I compute the average acceleration? We have 4 minus, we have 1 divided by 4 minus 1. Excellent. So I'm going to plug 4 into this function, and as we plug in 4, 2 times the root of 4, so I get 4 minus 6. Do I get negative 2 right away? So I have negative 2 minus, and then what if we plug in 1? Get negative 4? So it's a plus 4 divided by 3. So it looks like I get 2/3. Okay, work with the person next to you, see if you can find the exact acceleration at time equals 4. Try to do that without our help. Go ahead. Exact acceleration at time is equal to 4. Go. How is it that we determine acceleration? We take the derivative. What is the derivative of 2 roots of x? Or 2 roots of t? Yep, hopefully you came up with the derivative, which is 1 over the root of t. You simply just plug in 4, and you get 1 over 2 is the acceleration. So is the particle speeding up or slowing down at time equals 4? Talk to the person next to you, take a good minute, and try to come up with a justification or reason. Is it speeding up or is it slowing down at time equals 4? Go ahead.
Wait, what two?
So it's either the same or the opposite. We're looking for acceleration, and we're looking for velocity. Nope.
Acceleration.
Take another 30 seconds. Okay, the acceleration at time 4 we've already seen is 1/2. So I should write, excuse me, the acceleration at time 4 is equal to 1/2. That's what we just computed. Velocity at time 4, I would need to plug 4 back into the original, right? And that should produce -2. And so is it speeding up or slowing down? Slowing down because A of 4 and V of 4 have opposite signs. And again, that's the exact language that they were looking for. I would hope that in the past 2 days, as we've covered area and volume, I know that you may not enter the AP exam and get 9s on those, but I would hope you would say that, hey, if we encountered that, we feel like we could get at least half of it correct, you know? And I just want to be clear that just because I ask the questions in this way doesn't mean they're going to ask them in that same way, but you could have a fighting shot. And by the way, you will not see A, B, C, D, E, F, G. You will see just A, B, and C, or A, B, C, and D. And after we go through 4 days of this type of review, we'll then start looking at some of those type of problems straight from the AP exam. You guys can start scoring yourselves. You're going to do a lot better with having a shot at doing some of these problems once we've done this basic review. And then we'll up the rigor a little bit more towards some other things. Just to get note where we're at, tomorrow is Wednesday, is ACT day, but you guys will be taking this test on the 13th. So that provides us really with a half week here, and then 1, 2, 3, but really we're going to be testing right about here. So we've only got this week and about two weeks after that. So we've only got about 2.5 weeks to really kind of get after some of this material. Talking with a couple people, I will print off a full 2015 AP practice exam for anybody who wants to look at it, give it a shot. I want to be clear, just as you get after it, is getting 50% a good score.
Yeah.
Yeah, it is. So you must get used to looking at stuff and being confused, without a doubt. That's part of it. I continually hear from some people that they're like, wow, yeah, I was really confused for part of that. But so anyway, you guys can visit the rest of the hour. You have no homework tonight.